I was looking at the solar storm and those sunspots yesterday along with you all, and it was live, and we were all enjoying watching that show. And I myself was extremely surprised by how active the sun still is. It is supposed to be the end of solar cycle last year, like that, at least what was proposed. But this year is a lot more active than the last year. So we are in this 12-year solar cycle and we are at the maximum. And I'm extremely surprised by how active the sun is even this year. It is assumed to be slowing down and maybe less active by end of this year or maybe next year, we will see. And then it occurred to me, I need to give you a lot more information than this solar cycle. There is something more that we need to be careful and keep an eye than the solar cycle itself. So I wanted to bring that information here. So this is Ray. I take pictures of space using my backyard telescopes. Being a science commentator, I bring in a lot of science subjects, astronomy subjects, and I make a lot of live videos and videos as well. So if you are one of those people watching these videos, please don't forget to subscribe. It's going to help the channel as well, and give me an early like. So I wanted to take you back to close to 1600s and 1800s. Back in 1600s, we know Galileo was using the telescopes to look at the planets. And in 1800s, there is a guy, Urbain, who is one of the astronomers. Urban, French astronomer, I didn't want to pronounce his last name. And he proposed that he is noticing a structural wobble in terms of the Mercury orbit. And he was proposing that there may be a planet out there that is closer than Mercury, closer to the sun than Mercury. That was his proposal. And astronomers caught on to it. The Sam Schwabe, one of the German astronomer, he really wanted to find this planet Vulcan. So he was using his telescopes, making recordings of the sunspots, because he thinks that sunspots are the best way to find if there is a planet passing by the sun, in front of the sun. And he was carefully making notes, not just 1 year, 2 years, 10 years, 12 years, 13 years or so. So interestingly, Sam didn't find the planet Vulcan, but what instead he found was, he found that the sun goes through a periodicity, an interval of solar cycles. So every 10 years or so, he's seeing a lot more sunspots than before, and he's seeing sunspots differently, depends on which year he is looking at, where those sunspots are getting formed, sometimes in the equator region, sometimes in the outer edges. And he proposed that sun may have a solar cycle, and there are times when sun is more active than normal. So that became pretty official, and I think it caught on. And later on, the Randolph Wolf proposed, he wants to go back, look at all the data from 1700 onwards and see if he can put a solar cycle track record out there. And now it officially became that sun has this 10, 11, 12, 13 or 14 years solar cycle. It does change from solar cycle to solar cycle. So the way we determine a new solar cycle is going to start would be, sun is pretty much no sunspots. That means almost like a fresh start. A new solar cycle started. That's how we get to know the solar cycle is restarting. So what started as finding planet Vulcan now have an official record starting 1755. We were able to record the solar cycle and when the solar cycle is at the maximum as well. It's a pretty interesting data we started collecting now about the solar cycles. And then the mystery starts. So here is the beginning of the mystery, right? So we collected now the data regarding the solar cycles. We also know when is the sun is at the solar maximum. The way we determined that is based on the number of sunspots year after year after year. And whichever year has more sunspots and more X-class flares, then we know that is the year when in that solar cycle the sun is at maximum. We are in the cycle 2025. We are in the solar cycle 25. And if you take a look at this right now, we are at around 160 plus solar sunspots right now. And the year before it was 116. And they actually predicted it will go down this year as well. But in fact, it turned the other way, right? So now if you look at the previous year's data, the years before it was 180 sunspots, cycle 23, and prior to that 213. And if you keep looking at this data carefully, the strongest solar sunspots that we have are 285. This was in the cycle 19. I believe it was in 1950s. That's when the Carrington event happened, and that's when the 285 sunspots did came in. And if you can go back in time, you can start seeing pretty much like I kept it at the baseline of maybe 100 plus, and 264, 285 is the maximum. That's how it is going on. Every solar cycle is different, and we are right now at 160. Keep that in mind. So we are not in the 200s yet, but we are still at 160. But we produced in the solar cycle 25, we produced several X-class flares as well. Compared to the last solar cycle, we produced a lot more X-class flares in this solar cycle. Now, here is where the story gets more complicated. To understand what the sunspots are and what the solar cycle is, let's understand a little bit about solar cycle, and then we'll come back to this story. So I wanted to quickly walk you through the sunspot life cycle. The sunspots are going to be formed on the sun, which is an active region, and those sunspots groups together. Because of the polarity of them, they create these filaments, and those filaments are going to be having these opposite poles. They create this extraordinary energy coming out of those sunspots because they are grouped together into one big giant spot. It's called an active region. And those are the ones sometimes will turn into a coronal mass ejection, which is going to turn into a huge X-class or whatever the level of flare that the sun might produce, which is a high-speed solar wind that will be passed towards the Earth, and which is going to cause an extraordinary aurora sometimes. That's the typical sun life cycle. Now, so when you take a look at the 11-year cycle, there is a solar minimum where when you look at the surface of the sun, there are no sunspots. So there is no active region. There is no strong filaments. There is no, extraordinary magnetic activity. And then the sunspots getting formed. That means from almost like no activity to the solar cycle started kind of. There are places where you will start seeing the activities of the solar spots getting formed. Now, as this activity gets consolidated and more active, you are going in towards the solar maximum. And once the solar maximum comes in, which is the second quarter of the solar cycle, you will start seeing that activity starts increasing. And what we are noticing right now is almost at the end of that particular solar maximum. So there is this buzz on the internet out there called micronovae, and they call it micronova as well. So now this is something is sensational right now on the internet. They're talking about there is a solar cycle of 12,000 years, and our sun is going to reset the civilization on the planet after that 12,000 years. It goes micronova, and then the civilization is going to reset. I was curious of the origins of the story. What I was able to figure out was they mixed several stories into one big giant story, and it started pretty recently. I wanted to make sure that micronova is not possible on a sun that is alive. Only that happens when a sun becomes dead, which is sun becomes neutron star, which is billions and billions and billions of years of sun's life later. Now, even that the sun has to become a white dwarf, it has to access the energies from the other stars, and once the hydrogen gets accumulated, it is going to explode that hydrogen into one giant energy ball, and it explodes that area, and it happens over and over again as it accumulates more. And that particular explosions are on white dwarfs. Our sun is not anywhere near white dwarf, or it's not happening anytime soon. This is like billions of years later. And then this 12,000 years, every 12,000 years came in from a different theory of the planetary axis that has nothing to do with either the solar cycle or this 12,000 years story that was popped up on the internet. So there is no micronova possible on the sun. We cannot have micronova, period. But that's not the end of the story, though. So there is a Japanese physicist who discovered some ancient tree rings, and while doing that, she found something really mysterious. What she found was there are time periods where the sun bursted out so much energy that she noticed that history on the tree rings itself. So she was watching the carbon 14 on the tree rings and found that there are periods of ancient life. We saw this extremely powerful solar storms came in and put in a lot of radiation into the Earth's atmosphere. And trees noticed that, and trees rings recorded that history. This is called Miyake Events with her last name. Those Miyake events are now official record of the sun's history. So these are the known Miyake events that were recorded so far. So there is no specific time period interval between them. Like you can see, back in 14,300 BCE, and then 7,000 BCE, then 5,000 BCE, then 660 BCE, and 993 in the modern time period. So it didn't happen in the new time scale that we are noticing from the 1 to 1000 or the 1000 to 2000, and now we are in the 21st century. We haven't seen in the last 1200 years or so any such event. So this event is going to be a superstorm, think of that way, from the sun. And I was actually more curious in terms of what does it mean? Is it bigger than the Carrington event? And is it going to impact the modern way we live? The answer is yes. Definitely, we have, compared to the storms when they came in before, improvised our technology with electronics, everything, GPS, satellites, computers, our microchips. All the communications are now relied on the electronics and the power grids So there is quite a bit of an impact that these storms can do. The good news is I'm going to have a part 2 of this video. What are we going to do for these solar storms? There is a lot of activity going on. It's not going to be a small explanation to give you, but the idea that I can provide you is we are now trying to build equipment that can withstand these solar storms. Even if we have a Carrington kind of event, there are places, not every one of the devices, but there are some of the devices now we are able to secure them without getting hit by the solar storm. We also have satellite monitoring capabilities. We have a newest satellite that is going 2030 by the European Space Agency as well. So I'm going to cover that in the next video. So if you ask me the takeaway of what we learned from the active solar system, we are looking at the sun cycle, the current solar cycle 25, almost coming to an end. Maybe this is the last year it is going to be that active sun. And even though it is active and maybe it is active one more year, we are looking at the sunspots that are not very alarming. They are in the 160, 170 range. And you have seen the history of the sunspots that I showed you before. They were a lot more than what we are experiencing right now. So from that perspective, even though we are experiencing a lot of solar activity, it is not compared to the historical records just in the last few hundred years or so. So from that perspective, I don't see alarming. What I see an alarming thing was we need to be prepared for any solar storm, like whether it is even the X-class flare or a Carrington kind of event, or the ones that is like a giant event like Miyake kind of events. We need to be prepared. I think that's what the takeaway from this video is. I hope you like this video. Please do subscribe to my channel. Don't forget to subscribe to my channel. Thank you everyone for watching. If you like this video, please like, share, and give me a hype. Thank you very much. I'll see you all tomorrow.